Hello. Good evening, everyone. It's nice to see us here again. And welcome to today's live stream. Today we'll be talking about chemistry, past questions and answers on WASSCE. And we'll be dealing with the atomic structure, past questions and answers, as you guys can see on the thumbnail on your screens. So we are going to be dealing with the past questions. But then again, whatever you guys said we should do, that is what we are going to do. All right, so guys, as always, let's introduce ourselves in the live chat and comment in the chat where we are joining the stream from so that we can appreciate and give a shout out to the members of those beautiful country. All right, so we have Debbie from Ghana. Hi, Debbie. Thanks for joining. I think others will be joining very soon, so let's have some patience and wait for them. All right, so as always, we have some rules that we need to follow or abide by. That is, you come, you introduce yourselves, and then as you can see, we have some set of questions which are multiple choice questions. We have the questions, you guys can see it. So I read the question out, and then you guys will give the answer in the live chat. So what I expect is I'll read a question, call the possible answers, and then if it's question number 1, you just write question number 1. If the answer is A, you write A. If it is B, you write B. If it is C, C, and if it's D, D, and so on, like that. That is how the stream is going to be. All right, so whilst we wait for others to join us, let's quickly get ready. These are some of the questions that we'll be looking at. So just a minute and I will be back for us to continue. They show for the list. It's a dirty bed issue. All right, guys, thank you so much. So now let's start. Since most of our regular students are not in yet, Gigi is not here yet. Gosh from yesterday, as well as Asim, they are all not here yet. Okay, but we'll start regardless, and we'll wait for them to join us. All right, so the first question we have here is a very simple chemistry problem. Okay, so I'll read the question. You guys let me know the answer. Okay, I read the question, I call the possible answers, and you guys let me know the answer. Where we'll be having calculation questions, I will be solving them for you to see, so you don't have any problem. All right, then let's start with the first question. The first question is, the number of protons in an atom is known as its. The number of protons in an atom is known as its A, mass number, B, atomic number, C, neutron number, and then D, nucleon number. So the number of protons in an atom is known as its A, mass number, B, atomic number, C, neutron number, and then D, nucleon number. So guys, what is the correct answer? Just write the question number and the correct answer alongside it in the live chat. So an atom having the number of protons that we find in atoms, how do we call that? Or what do we call the number of protons in an atom? What is the name? Is it mass number? Is it the atomic number? Is it the neutron number? Or it is the nucleon number? Okay, very good. So the correct answer here is the atomic number. Okay, so the atomic number is the number of protons in an atom. Are you okay? Now for a neutral atom, it will be the same as the number of electrons. That is for neutral atoms. Okay, for neutral atoms. But for on a normal basis, an atom having a set number of protons, that protons are what we call the atomic number. Are we okay? All right, so let's move on to the next question. We have which subatomic particle has zero charge? Question number 2. Which subatomic particle has zero charge? We have option A, proton, option B, electron, option C, neutron, and then option D, positron. Which subatomic particle has no charge? We have option A, proton, option B, electron, option C, neutron, and then option D, positron. Okay, Jonah, hi, and thanks for joining. Hi. So we are solving some questions over here. So just mention the correct answer, and then we are good to go. Okay, so hi Jonah. So we are on question number 2 before you joined, and the question reads, which subatomic particle has zero charge? Okay, so we know that the atom has some atomic particles, and then some are proton, electrons, neutron, and positron. So we are saying that which of them has no charge? Is it a proton? Is it the electron? Is it the neutron? Or is it a positron? So guys, what is the correct answer over here? Okay, anyone with the answer? Okay, so guys, the correct answer here is the neutron. Okay, the neutron. So the proton is a positively charged subatomic particle. The electron is a negatively charged subatomic particle, and then the neutron is a neutral subatomic particle. So the correct answer here is option C. Option C. All right, beautiful. Now let's move on to the third question. The sum of the protons and neutrons of an atom is called the sum of the protons and neutrons in an atom is called, we have A, mass number, B, atomic number, C, neutron number, and then D, nucleon number. Question number 3, we are saying that the sum of the protons and neutrons in an atom is called A, the mass number, B, the atomic number, C, the neutron number, and then D, the nucleon number. So guys, what is the correct answer for this particular question? Okay, anyone from our live audience? All right, so the correct answer here is the mass number. The mass number. So when we add the number of protons and neutrons in an atom, what we get is what we call the mass number. We already saw what the atomic number is, and we said that is the number of protons in the nucleus of the atom. Are we okay? And then the mass number we are saying is the sum of the protons and the neutrons in that particular atom. All right, let's move on to the next question. So the next question is on isotopes. So question number 4, isotopes of the same element differ in their A, number of protons, B, number of neutrons, C, atomic number, and then D, chemical properties. Isotopes of the same element differ in their A, number of protons, B, number of neutrons, C, atomic number, and then D, chemical properties. So guys, what is the correct answer for this particular problem? And guys, for those of you who are watching and this is something that you like, going through past questions while we solve, I'll be solving and you guys will be seeing. If this is something that you find really helpful, or you know a colleague or a friend who is still in school, high school to be specific, and they will find this live stream very helpful, and make sure you share the link to the stream with them, or share the link to the channel with them, so that they subscribe to the channel and then follow us for daily live streams and solving of past questions. Let's prepare for next year as we write our WASSCE or SAT or even JAMB for those of us who are in Nigeria. All right, so the question we have here is question number 4. Isotopes of the same element differ in their A, number of protons, B, number of neutrons, C, atomic number, and then D, chemical properties. So guys, what is the correct answer? Okay, very good. So the correct answer here is the number of neutrons. the number of neutrons. So isotopes are of the same element. They have the same atomic number, which is the same number of protons, but they have different mass number, and that difference in mass number is due to the differences in their neutron numbers. Are you okay? So if they have one will have a proton of 5, the other one will also have a proton of 5, but the other one may have a neutron of 5, but this one may have a neutron of 6. Okay, so because they have the same number of protons, okay, they are of the same element, but the differences is in their mass numbers, which is as a result of the differences in the neutron numbers. Okay, and so that is what we are saying. That is what makes them isotopes. Okay, so isotopes are elements of the same compound, but they have different mass number due to the differences in their neutron numbers. All right, let's move on to the next question. The relative atomic mass of an element is the relative atomic mass of an element is the A, mass of one atom in grams, B, the average mass of isotopes relative to carbon-12, C, number of protons and neutrons, and then D, mass of nucleus only. Okay, so we are saying that the relative atomic mass of an element is the option A, mass of one atom in grams, option B, average mass of isotope relative to carbon-12, option C, number of protons and neutrons, and then option D, mass of nucleus only. So guys, what is the relative mass of an element? The relative mass of an element. Guys, what is your answer? Anyone from the live chat? Okay, so the correct answer here is option B. So the relative atomic mass of an element is the average mass of isotopes relative to carbon-12. Are you okay? All right. H is saying physics teacher. Yes, I teach chemistry, physics, mathematics, biology, all of them. Once they are for high school students, I teach that. But when we go to the university, I'll have to limit it to solely chemistry and mathematics. Okay. But I also teach physics as well. I think last 2 days ago we did physics. We did physics last 2 days ago. So Hichi, I hope I'm pronouncing the name right. Correct me if I'm wrong. But Hichi, thanks for joining the stream. We are looking at some chemistry questions which are also applicable in physics. So yes, you look in college, bro. You are too young. Ah, okay. I may look young, but I graduated university in 2021. Okay, I've been out of school for some time now. So yes, I graduated university 2021. I did chemistry, Bachelor of Science in Chemistry. Yes, that's what I did in the university. Okay, I'm currently pursuing my master's in a different field, not in chemistry, in a different field. But yes, even though I look young, I'm not in my 30s yet. But yes, I teach. I don't teach college, but I teach high school. Right. All right. I only teach online. I don't teach in a classroom. I only teach online. Right. I work in a food factory as a lab analyst, but online I'm a teacher. Right. All right. So yes, Hichi, thanks so much for joining. And let's proceed with the next set of questions. Okay. So we have question number 6. Okay, Hichi, I would love for you to give me the answer to this question. Okay, Richie, I'm a Ghanaian. I'm from Ghana. Okay, so yes, I'm streaming from Ghana, live from Accra. Okay, the capital of Ghana. Yes, I'm streaming from Accra in Ghana. Okay, so yes, let's continue. We have question number 6. What is the maximum number of electrons that can occupy the third shell? What is the maximum number of electrons that can occupy the third shell? We have A, 8, B, 18, C, 32, and then D, 2. Okay, Juliet is here. So Juliet, thank you so much for joining, and thank you for calling the answer. Okay, so Juliet is saying C, Fidelity Max is saying C, and then Hichi is saying B. Okay, so guys, I have 3 people mentioning the answer, and the correct answer is option B. It's 18, not 32. Okay, so the correct answer is B. Okay, so let me write that in the chat. B is the correct answer. Okay. Yes, so B is the correct answer for that particular one. So Juliet, thank you so much for trying. Fidelity Max, shout out to you for also trying. And then Hichi, you had it right. The correct answer is option B. Yes, thank you so much. All right. So the first shell takes 2. The second shell takes 8. Okay. But the next shell after that, which is the third shell, takes 18. Are we okay? All right. So let's proceed to the next question. The electronic configuration of sodium, okay, with the atomic number of 11 is, the electronic configuration of sodium with the atomic number 11 is, we have option A, 281, option B, 29, option C, 83, and then option D, 272. Okay, so the electronic configuration of sodium Z, which is equal to 11, is, we have option A, 281, option B, 29, option 3, 83, option D, 272. Okay, so Hichi is saying, I recommend using Kahoot, bro. It's easier and more interactive. I agree. In fact, let me even take notes. So I will try and see how Kahoot works and how best I can draft the questions for us to see. Okay, so that it will be in the browser. But because I wanted you guys to see it very big, that's how come I'm using my slide. But I'll try the Kahoot as well. Thank you so much for recommending that, Hichi. And yes, Fidelity Mass is saying option C. Juliet is saying option A. Hichi is saying option A. Yes, so the correct answer is option A. Okay, the correct answer is option A. That's for the electronic configuration of sodium. The correct answer is option A. Thank you so much. And thanks for trying, Fidelity Max, but your answer is wrong. All right, so let's look at the next question that we have. Okay, which particle is responsible for chemical bonding in atoms? Which particle is responsible for chemical bonding in atoms? We have A, the proton, B, the neutron, C, the electron, and then D, the nucleus. Which particle is responsible for chemical bonding in atoms? We have A, the proton, B, the neutron, C, the electron, and then D, the nucleus. So, Juliet, Hichi, any answer for me? Which particle is responsible for chemical bonding in atoms? Guys, any answer for me? Okay, so Hichi is saying A. Juliet is saying C, I think. Okay. Yeah, so the correct answer over here is electron, which is option C. Yes, electron is the correct answer over here. Because the proton and then the neutron are in the nucleus. Okay, so they don't take part in chemical reaction. So it is the electron that is responsible for chemical reaction and forming bonds with uh, uh, other particles, other elements when it comes to chemical bonding. Yes, so the correct answer here is option C. Okay, option C. Very good. All right, so the next question we have is a problem of the day. Okay, it's a problem of the day. And looking at the students who are actually online right now, I don't know whether we can solve this, but let's give it a try. Okay, if we can't solve it, then I have other objective questions here. I can read it out and you guys can mention the correct answer to me, and then we'll look at the the solution to this problem later. Okay, if that is all right with you, Juliet and Hichi. All right, so the problem we have here is that we have copper has two natural isotopes, that is copper 63 and then copper 65. They all have the atomic number of 29. What is the percentage by mass of the lighter isotope if the relative atomic mass of copper is 63.54? Okay, so this is typical for chemistry students who are doing chemistry as the Juliet, if this is something you can attempt, let me know in the chat. If not, we can proceed to look at more objective questions. Okay, so we don't have Juliet here. Okay, so since Juliet is not answering, let's proceed to look at the solution to this particular problem. Okay, so let me quickly come to my draw tab, select my writing tool, and then yes. So I'll take the question again. I have, okay, so Juliet is saying I should solve it. Okay, so the question is copper has two natural isotopes. Copper has two natural isotopes, that is copper 63 and copper 65. What is the percentage by mass for the lighter isotope, which is copper 63, if the relative atomic mass of copper is 63.54? So that is the problem that we have. Okay, so let's go ahead and look at the solution to this particular problem. All right, so for us to calculate relative atomic mass, so I'm going to use RD as the formula for relative atomic mass. So relative atomic mass is the summation of, into bracket, the mass number multiplied by the relative abundance bracket close, all divided by the total abundance. Okay, so this is the formula for calculating the relative atomic mass of an isotope, right? Now, if you look at what we have over here, we have the atomic number. So let me use A to represent. So atomic number for the copper is 29. Are we okay? Now, the mass number for the lighter copper, so I'll use that M1. The mass number is the number at the top over here, which is 63. Then the mass number for the second copper, so let me make that M2, is 65. Okay? Now we've been given the relative atomic mass of copper to be 63.54. It means they have already done the calculation for the relative atomic mass for copper and they have given us 63.54. Okay, so it means that my RD over here is what I have over here, 63.54. So I have 63.54, and this will be equal to, then into bracket, the mass number. Remember, so the mass number will be M1 over here. That's for the lighter copper multiplied by the relative abundance. Okay, the relative abundance, which I'll use R1 over here. Then multiplied summation, so it will be plus. Then M2 multiplied by the relative abundance, R2, all over total abundance. Now, the total abundance most of the time is 100. Okay, it's 100, but that will be R1 plus R2. But R1, R2 usually gives us 100. Now, to calculate the relative abundance for these two guys, because we've not been given, we add 60, we find the percentage of this. Are you okay? So now let's proceed. So we have to percentage by mass. Okay, so let's proceed. Juliet, I hope you understand up until this point. Juliet, I hope you're on the same page before we continue. Okay, all right, fine. So let's proceed. Okay. Now for us to find the percentage for M1 and M2, okay, so for us to find the percentage, we are going to represent this guy as this. Now we have to find the percentage for R1. We don't know that of R2 as well. So what it means is that in place of M1, we have 63 over here. So I'll write 63 over here. Okay. Then multiplied by R1 over here, we don't know. Are you okay? So we are going to represent it by, let me represent it by Y. Are you okay? Then plus into bracket M2. The M2 over here is 65. So I bring here 65 multiplied by, now the R2 over here, like I said, R1 plus R2 will give you 100. So since we don't know the percentage for R1, we don't know that of R2 as well because the question has not given us. So in place of that, we'll do 100 minus Y. Are you okay? Then all divided by Y, which is for the R1, then plus the R2 is 100 minus Y. Now, why this is the case is that, like I said, the relative abundance, if you add the two of them, you are going to get 100 things that much. But yes, so from here, we can proceed to solve the problem. So I have here 63 multiplied by Y. That will give me 63Y. Then plus, I have here 65 multiplied by 100. That will give me 6,500. Then 65 multiplied by negative Y will give me minus 65Y. Then all over, let me use a different color over here to show this. Okay, so here we have the denominator over here, we have Y plus 100 minus Y. Now, the Y over here is positive, the Y over here is negative, so they will cancel each other out. So we are only left with 100 at the bottom. Are we okay? So from here, let me quickly bring this up. So the expression we now have looks something like this, 63Y. So we have 63Y. Let me use white so that we can see well. So we have 63Y over here, then plus 6,500. So we have plus 6,500. Then minus 65Y. So we have minus 65Y all over 100. Remember, this is all equal to what we have over here, which is 63.54. 63.54. So in this case, I'll bring it over here, 63.54. It doesn't change anything. It is still the same. Okay. So over here, what we do is just basic mathematics. This guy also has 1 as the denominator. So we will do our usual cross multiplication over here. We'll use this to multiply this guy to multiply the 100. That is what we do from here. Okay. So this implies that we have 1 multiplied by everything at the top over here, which will give us 63Y plus 6,500 minus 65Y. And this will be equal to 63.54 multiplied by 100. Okay, so let's look at that just to avoid any form of error. So we have 63.54 multiplied by 100. That will give us 6,354. Okay, so now that we have this over here, we can proceed to find a solution to our problem. Now, remember we have 63y here and then negative 65y over here. So if we do the subtraction, we are going to get 63y minus 65y will give us negative 2y. Okay, then that will be equal to, this side of my equal to sign is still here, so we have 6354. Then I'll send the 6,500 to the other side of the equal to sign. It becomes negative, so that will become minus 6,500. So I have here minus 2y will be equal to, so I now have 6,354 minus 6,500. That will give me negative 146. Are we okay? So from here, I divide both sides by negative 2 by negative 2. This will cancel this. So my y is now equal to, the negative will cancel this. So 146 divided by 2 should give me 73. Okay, and the 73 becomes my answer to this particular problem. Mind you, the question is saying we have to calculate what is the percentage by mass of the lighter atom, isotope. Okay, so the percentage by mass here is 73%. What it means is that if we look at this, it means that R1 is 73%. So R1 in our case is 73%, which is what the question say we should find or identify. Now the R2, remember we said that the R2 is represented by 100 minus y. So therefore we will have 100 minus y, which is equal to 100 minus 73, and that will give me 100 minus 73 will give me 27, so 27%. Are we okay? Which therefore means that copper 63 and then copper 65, copper 63 and then copper 65. Okay, you have 2929 here. Okay, which means that for copper 63, which is the lighter one, the percentage abundance is 73%. And then for copper 65, it has a lesser percentage, which is 27%. Juliet, I hope you've understood up until this point, and I hope the whole calculation process makes sense. Juliet, are you still with me? Okay, so but basically this is how we solve this particular problem. This is sometimes you'll be given the percentage of one and you have to find the percentage of the other. Okay, but other times you will not be given the percentages at all. So when you're not given the percentage at all, as in this case, you have to represent 1 by 100, 1 by y. Okay, so Juliet is saying, can you repeat from where you were canceling the y, please? Okay, so let's go back there. Okay, this side. All right, so basically what I would do for you, Juliet, is that let me do the calculation, but from here, this is the formula. Okay, we are saying that the formula is the mass number multiplied by the relative abundance all over total abundance. Are we okay? So this point, I'm sure there's no problem. Okay, now the question, we have copper 63 and then copper 65. So let me do that over here. Copper 63 and then copper 65. Okay, so we don't know the percentages of copper 63 and then copper 65 present in the isotope. So we want to find that. Now for us to do that, we are representing copper 63 by y, the percentage present by y. And because the total percentage is 100, we have to represent the second one by 100 minus y. Are we okay? So all we did over here is that we took the atomic number, the mass number for copper 63, which is the 63. We took that 63, then we multiply it by the relative abundance, which we are saying is y for copper 63. So we multiplied it with y over here. Let me use a different color. so that you can see well. Okay. So over here, all I did was I took the mass number and I multiplied by the percentage in terms of variable. So it becomes 63 multiplied by y, as you can see over here. Then plus the second one, which is copper 65, I took the mass number, which is 65, and multiplied by percentage abundance. So which is now 65 multiplied by 100 minus y. Now the formula is over total abundance, which is R1 plus R2. So R1 is the y over here. The y over here is the R1 plus the R2 is 100 minus y. So we have here 100 minus y. Are we okay? Now we have positive y over here, negative y over here. It's like positive one, negative one. They will cancel each other out. So that is how come I cancelled the y's out. And then we're only left with the 100 in the middle. And this is what I have over here. So basically, let me erase this and redo the calculation from here so that you will understand. Okay. Okay. So basically what I'm saying is that copper 63 has a percentage. That percentage, we are making it y%. Are you okay? And then copper 65 also has a percentage, which we don't know. So it will be 100 minus y. Are you okay? Now, the formula is you use the mass number at the top and multiply by the percentage. That is the formula. So here will be 63 multiplied by y, then plus the second side will be 65 multiplied by 100 minus y. So we have here 65 multiplied by 100 minus y. Okay, then all over the total abundance will be the sum of R1 and R2, which is y plus. So it become y plus the second one, which is 100 minus y. Over here, you can see positive y, negative y here. They will cancel out. Okay, positive y, negative y, they will cancel each other out. Okay, and that is how come we are getting just 100 over there. So Juliet, that's up to this point. Does it make sense? Do you understand? Okay, I believe it does. Okay, so once this guy cancels this guy out, yes, thank you for replying. So once the y, positive y cancels the negative y, we only have 100 left. So all you have to do is to expand the top. So 63 multiplied by y will give me 63y. Then plus 65 multiplied by 100 will give me 6,500. 65 multiplied by negative y will give me negative 65y. All over. Like I said, this already cancels this. So we only have 100 left at the bottom. Okay. And this has a denominator of 1. So as in the next slide, you just cross multiply and then solve for the value of y. And in this case, the value of y that we obtain is 73%. Okay. Like I said, depending on the question, sometimes you'll be given the percentage of 1 and then you have to find the other percentage or calculate the relative atomic mass itself. But sometimes you'll be given the relative atomic mass and you will not be given the percentages, and then you'll be asked to find the percentage of one or even both. And this is how we do the calculation. Okay, so all that is from here all down here is just simple mathematics or basic mathematics, change of subject, and then you do your calculation and then you get your answer. But the solution to this problem is for copper 63, which is the lighter copper, it is 73%. And then the other isotope, which is copper 65, has 27% abundance present. Okay. So Juliet, I hope this brings home the problem that we have over here. Juliet, I hope you understand and we can continue. Okay, very good. So Juliet, I have another problem over here. It is the same concept, right? So the formula is over here. Uh, Relative atomic mass is equal to mass number multiplied by relative abundance all over total abundance. And then this is the next question that we have. So we have here an element X has two isotopes of mass mass numbers 18 and 20. If the isotopes are present in the proportions 1:2 respectively, what is the relative atomic mass of X? Are you okay? So is this something you want to try, or we should do it together? Julia, do you want to try, or we should do it together? Julia, do you want to try yourself, or we can do it together? Okay, she said we should do it together. Okay, so we will do it together. So over here, let's note the things that we have. So we've been told that the element X has two isotopes, okay? So one has the mass number, let me say M1 is 18, and then for the second mass number M2 is 20, okay? Now, if the isotopes are present in the proportions, so it means that the proportion 1 is for the 18, the 2 is for the 20. So it means the relative abundance, which is R1 for 18 is 1, and then that's in terms of ratio. And then for the 20, R2 will be what? 2 over here. Are we okay? Now we have to calculate the relative atomic mass of X. Now what you can do is that you can find the total ratio, which is 1 plus 2, which is 3, and then calculate it percentage wise to get a percentage of R1 and R2 and use in the calculation. Or you can just go ahead, proceed, and then solve the problem like this. So let's proceed. So relative atomic mass for isotope X is equal to, we quote the formula, the mass number multiplied by the relative abundance, okay, all divided by the total abundance. Are we okay? So from here, the relative atomic mass of isotope X will be equal to, now the first one, the mass number is 18, the ratio is 1, okay? So let me rewrite this. This will be M1 multiplied by R1, then plus into bracket M2 multiplied by R2, all over total abundance will be R1 plus R2. Okay, so Juliet, I hope we've understood up until this point, where we have the R1 and then the R2 plus R2 at the bottom. I hope you understand up until this point. Okay, I believe so. So let's proceed. So basically, the relative, this will be equal to the M1, like I said, is 18, and then the R1 is 1. So we have 18 multiplied by 1 plus the second one is 20 multiplied by 2. So we have here 20 multiplied by 2 all over R1 plus R2. That will be 1 plus 2. Okay. So over here, you just proceed to do your calculation. So 18 multiplied by 1 is 18 plus 20 multiplied by 2 will give me 40. all divided by 3. And then this will be equal to 18 plus 40 will give me 58 divided by 3, and this will be equal to, so 58 divided by 3 will give me 19.3. 19.333. It's recurring, so we write it like this: 19.33 recurring. So this becomes the solution to our problem. Juliet, I hope we understand. Juliet, do you need any explanation anywhere, or we can proceed? Oh, and the unit for relative atomic mass is atomic mass unit, AMU. So ensure to add that. Okay, so this is the solution for this particular problem. Okay, so she's saying we can proceed. Very good. So let's proceed. I'm trying to get more questions similar to that. Yeah, so the first one that we solved earlier for copper 63 and copper 65, that was an objective question. That is for June 2003, question number 5. So the correct answer there was option B, which was the 73%. And yes, exactly, that was what we had, 73%. Very good. And this particular one, I'm trying to find the question. Let me see the answer that they also have. Trying to get that. Just a minute. Okay, 19.33. Right, I think I would have to go through a lot, but that is the solution to the problem. There's no need. That is the solution, and then we are good to go. Eddie is asking, where are you from? Eddie, I'm from Ghana, right? I'm from Ghana. I teach online here on my science tutorial platform. But yes, I'm a chemistry graduate from the University of Ghana. I did chemistry in the University of Ghana, and I'm teaching online. For the time being, I'm teaching online. All right, so please like the stream and then subscribe to the channel. Okay. All right, let's look at another question. All right, let's look at another question. Now, this question is quite loaded. So let's look at what we have. Okay, just excuse me. Okay. All right. So this question, like I said, is quite loaded. Let's read the question and look at the solution to the problem. We have the element Q has two naturally occurring isotopes. That is Q35 and Q37 with relative abundance of 75.5% and 24.5% respectively. Okay, so if you look at this one, Juliet, if you look at this one, you can see that we've been given the two isotopes, isotope 35 and isotope 37, and we've been given the percentages already. So this one is very easy. You just put them into the formula, multiply, divide by 100, and then you get your answer, okay? Very easy. So now the first question they ask is, what do the subscript and superscript in the symbol for the isotopes of Q represent? Okay, now this is very easy. The I part of the question is very easy. Okay, the I part of the question is very easy. Now the I part, we have to calculate the A, relative atomic mass of Q. Very easy, okay? The second part, the B, is molecules of Q2 that are present in 17.75 gram of Q2. Are you okay? The molecules of Q2 that are present in 17.75 grams of Q2. And then we've been given the Avogadro's number L to be 6.02 times 10 raised to the power 23 particles per mole. Are we okay? So, Juliet, do you want to try this question, or we should do it together? Okay. And then the I part of the question, what do the subscript and superscript mean? We'll be looking at that very soon, okay? But Juliet, do you want to try your hands on the question, the calculation part, which is the II? Do you want to try your hands on it before we solve it together, or we should do it together as always? Okay. Seems like we lost Juliet a little, but all the same, we will proceed. We'll proceed first. Okay. Now, for instance, let me just quickly do this over here. Okay. So when we look at the element Q, let me take just one of the isotopes, Q 35 and then 17. Okay, so this is one of the isotopes. Now, when we take this as our isotope, the one at the top over here is what we are calling superscript. Superscript. Are you okay? And then the number at the bottom over here is what we are calling the subscript. Are you okay? So this is what we are referring to as superscript and subscript. These are what we are referring to. The number on top of the isotope is what we are calling the superscript. The one at the bottom is what we are calling the subscript. Now, we all know that the one at the bottom, okay, is the atomic number. Atomic number. That is the number of protons present in that particular element. Now, the one at the top, which is the superscript, is what we are calling the mass number. The mass number. That is the number of protons and neutrons present in that particular element. Are you okay? Right. So the I part of the question, what does the subscript and superscript represent in the isotope Q? The superscript is the mass number, the subscript is the atomic number. Okay, and that is the solution to question number I. Are we okay? That is the question. Now for II, let's proceed to look at II. We have to calculate the relative atomic mass of the element Q. Okay, so the relative atomic mass for the element Q. Okay, so the relative atomic mass for the element Q is equal to, we quote our formula, that is the summation of, it is the mass number multiplied by the relative abundance all over the total abundance. Okay, so to calculate the relative atomic mass of the element or the isotope Q, it is the summation of the mass number multiplied by the relative abundance. So it's relative abundance all over total abundance. Okay, so let me quickly remove this. Okay, all right, so this is the formula. Okay, now if you look back at the question, we realize that for isotope 35, the percentage abundance is 75.5%. Okay, that is the first one over here. So let me use the colors. So for this isotope, this is the percentage abundance, 75.5%. For the isotope 37, let me use a different color for that as well. For the isotope 37, this is the relative abundance, 24.5%. So now that we know 35 is 75.5 and then 37 is 24.5. Let's proceed to look at the solution to this problem. So I'll take my white again. So the relative abundance for Q will be equal to, so we have isotope 35, and then the relative abundance is 75.5, so we have 75.5%, plus for isotope 37, the relative abundance is 24.5, okay? And then the total abundance will be the sum of the individual abundances, which is 75.5 plus 24.5. Are we okay? So from here, all we need to do is to continue our calculation. So if I multiply 35, let's do that. So 35 multiplied by 75.5 is 2,642.5. That is what my calculator is giving me. So over here, I have at the top 2,642.5. Then plus the second part, which is 37 multiplied by 24.5. Okay, and that will give me 906.5. So I have 906.5, all divided by the denominator over here, 75.5 plus 24.5 will give me 100. Okay, so over here, the relative atomic mass for Q will be equal to, now, 2,642.5 plus 906.5 will give me 3,549. Okay, and then that will be divided by 100. And so if I compute this into my calculator, 3,549 divided by 100, so this divided by 100 will give me 35.49 as my answer. Are you okay? So my answer for this particular question is 35.49. Okay, now the unit, you can add AMU, atomic mass unit, or you can leave it, right? But this is the answer for the IIA part of the question, the relative atomic mass of the element Q. That is the solution. So this is the solution to that problem. Now for the next one, which is the II, the molecules of Q2 that are present in 17.75 gram of Q2. Okay. Now for that, we just calculated the relative atomic mass for Q. Okay, so Q is equal to, the relative atomic mass of Q is 35.49. So we have here 35.49. So for Q2, okay, it means we have 2 of Q present, and that will be equal to 2 multiplied by 35.49, and that will be equal to 70.98 gram per mole. Okay, that is the amount of Q that will be present in Q2. Are we okay? Now when we want to calculate the number of moles, okay, the number of moles present in Q2, we know mole is mass over molar mass. Okay, so the moles of Q2, so N of Q2, the moles of Q2 is mass over molar mass. And then the question gave us the mass to be 17.75. Then we divide by the molar mass, which is the 70.98. So if I compute that into my calculator, 17.75 divided by 70.98 that is going to give me 0.25 mole. Okay, so this is the amount of substance that is present in Q2. Okay, remember we calculated the relative atomic mass for Q, and we say if the relative atomic mass is 35.49, then in Q2 it means we have 2Q present. So we multiply the 35.49 by 2 to give us the molar mass, which is 70.98 gram per mole, as we can see over here. Now, to calculate the amount of element present, we need to first find the amount of substance present, which is the mole. So the mole, the formula is mass over molar mass, which is 17.75 divided by 70.98, and that will be equal to 0.25 mole. Are we okay? So now that we have the mole, the number of molecules, capital N, number of molecules will be the mole, small n, multiplied by the Avogadro's number. Okay, so the number of molecules present is equal to the mole, which is small n, multiplied by the Avogadro's number, which is capital L. So this will be equal to, our mole is 0.25 multiplied by the Avogadro's number. L was given to us in the question originally. So if you look over here, we have the Avogadro's number is 6.02 times 10 raised to the power 23. Okay, so we use that to multiply this. So we have 6.02 times 10 raised to the power 23. Okay, so if I do that multiplication, I am going to get 0.25 multiplied by 6.02 times 10 raised to the power 23, and that will give me 1.505 times 10 raised to the power 23. Okay, and if you want to write it to three significant figures, 1, 2, 3, so that will give me 1.51 times 10 raised to the power 23 molecules. Okay, so the last part of the question, which asks us to find the molecules of Q2 that are present in 17.75 grams, it means these are the molecules present in 17.75 grams of Q2. So these are the molecules present. Okay, 1.15 times 10 raised to the power 23 molecules. Okay, guys, so this is how we solve problems on relative atomic mass unit, especially when it comes to the atomic structure. Okay, these are some of the questions that are likely to come in your exam, right? Apart from the science, the names of particles like beta, neutron, alpha, and proton, and what are their relative mass and charges. Are we okay? Apart from that, most of the questions are going to be on the relative atomic mass and isotopes. Okay, calculating of relative abundance and isotopes. So that is basically what most of the questions will be about. Yes. So we have one last question left. Okay, so we have an element X with relative atomic mass this, and it has two isotopes. We have to calculate the relative abundance of each, but since we've lost Juliet, Eddie is also not around, so I'll skip this for another time because we've done a lot so far. So guys, any question, any suggestions? Someone suggested that I use Kahoot for the multiple choice question, and that will be more engaging. So well noted. We'll proceed from there. If the need be, we don't do any calculation, we will use Kahoot. But if we'll be doing calculations, we may not be using Kahoot, because if I have to write like I'm doing over here, I'm not sure Kahoot will give me the option for me to be able to write like I'm doing over here. Okay, that is how come I'm using the slide. But if Kahoot can give me that option, fair enough. Okay, I'll still go with that. So guys, any questions for me? Any suggestions? anything for me? Guys, any suggestion? Okay. So guys, in the absence of any question, any suggestions, I think we've done enough for today. I'm also quite tired. Okay, so I'll see you guys tomorrow, same time, 7 p.m. GMT. I'll see you guys same time. Probably we'll be looking at more multiple choice questions, uh, science, physics, chemistry, biology, any of them. Okay, but it's every day. The live stream is every day, every evening. We'll be doing the live stream, and then we get to learn. Okay, so guys, if this is something that you love and you love the fact that I had to take my time and do the explanation and everything, share with your friends, share with your colleagues who are in high school, and they may find this sort of learning, online learning, very educative and informative. Don't forget that this is Shacking Hour, and Shacking Hour is here for you guys. It's a platform where we learn live. You ask me questions, I answer. If you don't understand something, I explain and explain again. The subjects that we are dealing with include elective mathematics, core mathematics, biology, chemistry, physics. You just name it, we'll do it, right? Name it and we'll do it. And I also answer questions live. So if you have any question that has been disturbing you, you just go and watch any of our videos on the main platform. Drop the question there, and then I will attempt it, and then we can solve it on the stream. If not, if you want to send it to me personal, you can send it to me via email to mysciencetutorials@gmail.com. Okay, mysciencetutorials@gmail.com. All right, so thank you once again. I really appreciate today's session, and I still want to give a shout out to all those who were able to join right from the beginning. So I'm going to call them and give a one last shout out to all of them. So we have Deborah joining. So Deborah, a big shout out to you. We have Jonah joining. So Jonah, a big shout out to you. We have Hichi joining. So Hichi, a big shout out to you. Then we have Fidelity Max joining. A big shout out to you. Uh, who else? We have Juliet, who was one of the very few people. Juliet and Hichi, they were one of the very few people who were answering a lot of questions, right? So Juliet and Hichi, a big shout out to you. I really, really appreciate you guys for joining. Fidelity Mass as well, a big shout out to you. And then who else? And then we have one last person, Eddie, joining later on during the stream. And Eddie too, a big shout out to you. Now, if you want me to give a shout out to you, just leave your name in the live chat. I'll give a big shout out to you before we end the stream today, tonight. All right. So yes, anyone else? Okay. So guys, thank you so much. Then I'll see you tomorrow. Peace.